Hey Jason, alright, so we're looking at these problems on your homework here. Let's pull it up. So, they're asking us to use a dotted line to include the standard x squared parabola along with a sketch of each given function. Okay, so I'm not sure what you're comfortable with so far, so I'm going to kind of back up a little bit and lay a little bit of foundation for you here. So recall that with what we're talking about here is if we say f of x equals x squared, really what we're saying is if we plug anything in for x, it's going to give us an output. So if I say f of 1, well, that's simply saying 1 squared is going to give me 1. So if I were to graph this function, then if I plug in an x value of 1, which is right here, it's going to return a y value of 1, which is here. So if we said f of 0, well, that's 0 squared equals 0. That's here. Now what's interesting to note about quadratic functions or second degree functions like this is basically when you have an even function like this, an even power, sorry, it's going to give you a mirror image. It's going to be symmetrical along the y-axis, right? So if I took f of negative 1, right, well, that's negative 1 squared, and negative 1 squared, negative times a negative gives us a positive. So here's negative 1 on the x, and so it's going to give me that positive 1 on the y-axis. So let's say I took f of 2. Well, that says 2 squared. That gives me a y value of 4. So 1, 2, 3, 4. That's going to be here. If I said f of negative 2, that's going to be negative 2 squared. Well, a negative times a negative squared, right? That's still going to be positive. So that's going to give us this. So I could, this is going to be the graph of x squared. F of x equals x squared, or as your paper says, y equals x squared. It means basically the same thing. So let's start there, and your, let's see, this first one here. Okay, they've given us, for number 7, they've said f of x equals 2x squared. Okay, well, same principle applies. So let's say I'm going to do f of 0. Anywhere I see an x, I plug in that x value. So that's going to be 2 times 0 squared. Well, 0 squared is just 0, right? So 2 times 0 is still going to be 0. So if let's start doing our graph here. So this is my input, this is my output. So this is my x, this is my y. So that's going to put me right at the origin. Now let's do f of 1. So 2 times 1 squared. 1 times 1 is 1, times 2 is 2. So here's my input. 1 on the x-axis is going to give me a 2 on the y-axis. Let's do f of 2. That's 2 times 2 squared. So 2 squared is 4, times 2 is 8. I think I'm going to run out of room on my graph here, so let's just extend this upwards a bit. So there's 2, 4, 6, there's 8. So if I have 2 on the x-axis and 8 on the y-axis, well, there's part of my graph. But now we have to account for the fact that because we have a squared here, we're going to have something symmetrical about the y-axis. So I can take f of negative 1. And once again, I plug in 2 times negative 1 squared. Well, order of operations says I have to deal with this guy first. So negative 1 squared, negative 1 times negative 1, that's a positive 1, times 2 still gives me 2. So here's my negative 1 on my x-axis, and I end up at positive 2 still on the y-axis. Pardon me. And I can plug in, I take f of negative 2, so 2 times negative 2 squared. Well, negative 2 squared, that's going to be positive 4, right? Positive 4 times 2, that's going to give me an 8. So I am right up here. So my parabola is going to look like this. So now your instructions said that what they wanted a dotted line, to show the standard x squared. So, well, that's this guy right here. So we have 1 and 1, we have 2 and 4, negative 1 and 1, negative 2 and 4. So it's going to look something like this. So that's the first one. Let's take a look at the next one here. Okay. So number 8, giving us x equals 1/4 y squared. Well, we can basically do sort of the same thing here. Like up here, all we did is we generated an xy table. We used, these are our x values and these are our y values. So for x, we used negative 2, negative 1, 0, 1, and 2. And those return the values 8, 2, 0, 2, and 8. Well, you know, we could do the same thing here. We can generate our little t-table, and we can plug in whatever values we want here. So if we, okay, they're asking us to solve for x in this case, so I'm going to plug in some y values. Now, because I'm dealing with a fractional coefficient here, I'm going to find certain values to be more beneficial. If I just pick numbers willy-nilly, it's going to give me fractions over here, which I might not necessarily want. So I want to pick a y value that when I square it is going to give me something that's divisible by 4. For example, if I wanted to say y equals 2, right? So I plug this in, I get x equals 1/4 times 2 over 1 squared. So this is just a 2. I just turn it into a fraction by putting a 1 under it. Nothing special going on there. So 2 squared, that's going to give me 4. So I have x equals 1/4 times 4. Well, if you remember from vanilla fraction land, what we're talking about here is I can cancel those two 4s, any top, any bottom, right? Mix and match bikini sale. Any top with any bottom. So these cancel into 1s. So if y equals 2, that tells me that x, that x has to equal 1. So similarly, now let's see what would happen if I pick some other number. Let's say that I decided I wanted y to be 3. Well, what I have now is 1/4 times 3 over 1 squared, which is going to turn into 1/4 times 9, because 3 squared is 9. Well, there's no reductions I can do here, so I'm stuck with x equals 9/4. Now, while that's a valid number, it doesn't do us much good for graphing. It's kind of ugly. So that's why we want to pick numbers that are going to cancel nicely with that 4, right? So let's say y equals 4. So now I have x equals 1/4 times 4 squared. That turns into 1/4 times 16. So by 4 is 1, by 4 is 4. So this is going to give me 1 times 4 is just 4. So if my y equals 4, then my x is going to equal 4. And let's throw some negative numbers in here. So because 2 and 4 worked, let's just use the negatives of those. So we have -2. So x equals 1/4 times -2 squared. -2 squared, like we saw up here, is the same as +4. So I have 1/4 times +4. Well, we saw what happened right here, right? It just kind of unravels and goes poof. So if y equals -2, then x would still equal 1. And likewise, with -4, we're going to see the same relationship here. It's still going to give us a 4. So if we were to graph this, if we have an x of 1, we're going to have a y of 2. If we have and we will also have a y of -2. Because it's x equals, what that does is it shifts your graph 90 degrees. So we're going to have this. So if y equals 2, x has to equal 1. If y equals -2, x still has to equal 1. If y equals 4, 4, then x has to equal 4. If y equals -4, then x still has to equal 4. Now we haven't found a vertex yet, so let's see what happens if we plug in a 0. Let's say we decide that our y is going to equal 0. Well, that's going to tell us that x is going to equal 1/4 times 0 squared. Well, 0 squared is 0. Anything times 0 is just 0. So that gives us our origin. So here is the graph of the function x equals 1/4 y squared. Now we superimpose the standard y equals x squared, then we're going to get this same kind of situation that we had up here. So start with those. If you need any more help, let me know, and good luck and good solving, and I'm here to help you if you need it. Talk to you soon.